Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about an interesting development in Indian markets, household energy storage. So let's dive deep into it. So what exactly is the problem that we need a product like that is in my thumbnail, Ola Shakti, or basically power banks for homes? Well, problem is the world is moving towards what we classify as decentralized grid, meaning we are moving away from 1800s logic of having ginormous power plant or hydro dams and then they're feeding all the power to, well, every consumer. Now it's decentralized. So, and it's decentralized in many unique ways. For example, you have wind, you have solar, you have biogas, and many other things. Some even have wave power, some are working on geothermal. So you have very decentralized, meaning you have more than enough power, but it is not coming from one central point. So that creates a very unique problem. Second unique problem, it's extreme weather event, meaning you could have a scenario where your super duper magical nuclear power plant is there, everything is fine and dandy, and you have 1000 kilometer away from it, which is normal. You have a city, everything is fine, but here's it, something happens in between, basically for your high voltage transmission lines, earthquake, flooding, tornado, these sort of things, and kaput, your grid event kaput. So that also creates a scenario, and these things, basically extreme weather events, are becoming more common, meaning it's not like, oh, it might happen once in 100 years. It's like, oh, it happened every 5 years, so to say. And again, the frequency is increasing, meaning now I can say like every 5 years, and 5 years from now I will say, oh, almost yearly. So it is getting brutal. Now, all that is manageable until you reach the final boss, which is electricity cost is rising globally, meaning it does not matter which country you are in, prices of electricity units are going up. Now, of course, some countries are going shui, some are going slowly, but all of them are going up. And to rub a salt on the wound, some countries are giving subsidies to AI research, and they are subsidizing electricity by increasing your electricity cost. I'm like, that's just mean. That's just like, if you are poor. So that's just bad. But again, it is happening. So in that dark reality, solar is bright puppy, as in it's getting cheaper year over year. And again, if you are in one of those countries where solar is not getting cheaper, you have regulation problem, not technology problem. You have regulation. You may have like 50, 60,000 layers of regulation, and it might take 2 to 3 years to get a permit. You have regulation problem, not solar problem. Solar panel, good. Technology, good. If it can be done in China, if it can be done in India, almost everywhere else is also can be done. Of course, it may not give you the same uptime as in India or China. If you are in UK, you might have lower uptime, but it will still work. So solar is getting cheaper year over year, and more people are installing it, and it's like literally showing you reached a point where certain cities in USA is like daytime is like, yeah, what should we do with the power? They do not have a super duper well thorough big puppy interconnection between states, so they literally have a scenario where it's like, yeah, we have to shut it off. They have to do power curtailment. In modern time, they have to do power curtailment. How the heck that's even possible? Solar. So reality is, we are creating a very weird scenario where too many things are changing. First, you have instability in the real world. Then you have economic instability of inflation and all that. Then you have decentralized grid, which is changing the whole paradigm. And then more and more people are installing, that is amplifying all this effect. So you have to deal with surplus, and you have to deal with resilience of outages, meaning it's not comfortable to people, whereas like, again, nowadays we are so reliant on electricity, we can't go back to lighting a candle or things of that nature. It has to be there on all the time. So having tornado and all that, oh, it destroyed the high voltage line, yeah, it makes sense, but it's just like, it does not feel acceptable, so to say. So there is a problem, like we need to solve this. Now, how did we got to this position? Well, we got to this position because of development of what we call on-grid, aka grid-tie inverters. Now, government started subsidizing solars. Now, again, why the heck government would do that? Well, three things. Primary is job creation. It's government's job is to make sure there are jobs, not governmental jobs. Governmental job is like government paying itself taxes and then it's paying 30% less of taxes. It's useless basically. Basically, government jobs are like, actual government job is like a mobile. It's a lubrication oil. Fuel is private jobs. So you wanted to create jobs, so you create a structure. That was the reason why they poured money into solar. Another was manufacturing. So much manufacturing started to happen, even if your country, and I'm talking as far away as South Africa, even if they were buying cells from China, they were still manufacturing the panels in South Africa. So manufacturing became like a big boom event, and over time they reached a point of, hey, now we can make our own cells. So awesome thing, meaning a new sector started to come into market, lot of job creation, lot of manufacturing, and energy security, which means you can breathe easy, specifically for countries that have a very poor grid, b have to rely on imports of fossil fuel or things of that nature. So all these things made it a logical investment. It was not even a subsidy. It was more like, yeah, we are paying for power plant which was distributed. And this was another way they justified it, is like, if it's a grid tie inverter, they can know, like, I'm going to give you this much subsidy on this unit of energy system, meaning let's say my household has 2 kilowatt hour set 2 kilowatt panels. They'll give me some amount of subsidy. They will put a two-way meter in my household, and they can easily read out, hey, we give him this much subsidy, we get this many units of that. Based on a few years of data, they refine the subsidies and all that. So it makes sense for them. It's like, hey, buy solar panel, buy grid tie inverter, you use the power that you use, and if you don't use the power, we consume it during daytime, and during nighttime we give the power back to you. And although there is a bit of imbalance there, because again, grid will buy power from you for very cheap price, let's say 1x. By the time you are buying it as in like night, it will be 2x. So you do lose. It's not designed for your so to say benefit. It's more designed for your convenience, so you do not have to buy battery. So that's the give and take relationship, meaning you do not have to buy battery. We also get a sort of peak reduction during the daytime. And be mindful, factories go YOLO on daytime, so that's how they did. And all these things worked. People went YOLO on it. But if the grid fails, the power even during daytime has to stop, meaning these puppies are really awesome. They work. And be mindful, many of the modern ones are so good and so refined in terms of their control mechanism. They can run heavy loads on solar plates. This puppy, heavy loads directly. There is no battery. It's like, I got this. So that's amazing. But again, because it is working with grid tie, meaning it is directly connected to grid, it has a severe risk of what we call backfeed, aka how generator used to kaput people. As in, if you did not disconnect the system properly and generator fed back the power, transformer works exactly the same in both directions. For example, what you generally have 9 kV to 11 kV high voltage line coming to your basically nearest pole. That pole has a step down transformer. That puppy can take that voltage to, let's say, 220 volt. Cool, awesome, GG. Here's the deal. It will do the same thing if you dump a 220 volt. This puppy can dump 220 volt. It's designed to dump 220 volt. So it always has to be a follower of the grid, meaning if the grid is there, only then it dumps power. The moment grid goes offline, it's like, nope, it just nopes it. So, and again, lot of linemen has lost their life because of this. That's why like there is such a hard what you call rule set around generators. Like if you have generator, cool, awesome, no problem, but make sure you disconnect the grid. Like it has to be a physical interlock, that you cannot have these two things connecting with each other. This does not have that luxury because it's inherently sending electricity back to the grid by following the waveform. So it has to be like, yo, I have to be a follower. I cannot be the leader, because again, it can send the power back even during grid off time, which could create very serious hazard scenarios. So people have learned it the hard way. So these things have to shut off if grid goes down. Now again, those are extreme cases. Let's say some fault happened, but what if your grid itself is not uptime reliable? As in, if I live in India's Gujarat, Ahmedabad, power never goes out. Like the grid is good, stable, do not have to worry about it. But if you live in, let's just say, certain small places in Bihar, good luck. Power goes out way too often, way too much in summer, and that creates a paradox. The time you need it the most, it's offline. So, and not to mention, from economics point of view, you also have to pay the government or the grid operator for the two-way energy system. Now, be mindful, it's not the hardware cost. Almost all modern meter, as in made after 2010, is a two-way meter. Nobody is making one-way meter. It's like, bro, it may be old stock, but it's like two-way meter is there. It's just that paperwork and all that. And again, many of our colleagues did solar without even government subsidy, simply because it would have taken them a month or 2 months to get the regulation and all that. It's like, yeah, we are doing off-grid battery only. And it has no fail-safe, meaning if the grid goes down, you go down, even though you have the power. So that's a really bad scenario. Imagine something bad happened at night, grid goes down, cool. You're like, okay, during daytime, we'll be back online. You can't be back online because grid is down. That's a really shocking thing to many people. It's like, hey, I have solar. It's like, no, if you have grid tie solar, you just have a amplifier of sorts, solar amplifier. But signal has to be there. If there is no signal, there is no amplification, you kaput. So that's how we got started. And again, it is a very big burgeoning industry, but we reached a upper limit, so to say. Now, two vectors that limits how easily we can adapt to this situation is power and energy. And be mindful, these are two independent vectors. They have correlation to it, but they are independent. In simplest sense, think in this way. Your tap is your power, as in how much oomph you are giving out. For how long you give out, that translates to your energy capacity. That's power, that is energy. This is the best diagram I have seen. Like for 1 kilowatt, like in my scenario, it will 2 kilowatt. If it's working for 2 hours, that will be 4 unit of energy I will have in my tank. And how long my tank will last, that depends on how much power my equipments are consuming. So that is there. And it's a very complex mathematics if you want to calculate how much you need. If you're like, hey, I do not want to deal with the grid. Like grid does not exist for me. It's like, no sir. Like if you want that, like no grid sir, it's a 24/7 on solar. Can it be done? Of course it can be done. It's just that the mathematics is variable. Like of course you have Bill Gates, who cares? But if you do not have infinite money, it is brutal. Because again, you will think the easiest way to come up with it is like, okay, how many appliances I have, let's calculate all of their nameplate capacity, and that's your maximum power draw. But here's the deal, that's not real. Why? Generally not all of them will be on at the same time. That will give you the power, but it will not be all draining at the same time. And be mindful, your household circuit breaker will trip if it was doing that. So like you have air condition, that is a very heavy energy load puppy, and then you have water heater. Both again in India, they are not generally do not work at the same time. If we are running AC, we are not running water heater. Again, it's maybe a bit different in other places, but in India, it's like, yeah, those things rarely happen at the same time. So you can see like that creates a scenario where your metric, how much kilowatt you need, could be completely off. You may be like, okay, I need to buy 50 kilowatt in terms of power. So it is not as easy. Another aspect is, okay, that's kilowatt, as in like how much oomph, how powerful is your generator, how big is your tank, as in energy or capacity, or units, as in kilowatt hour. That's even harder to calculate. Like flat out, it has so many variables. Now, easiest way to calculate this realistically, just look out your electrical bill and jot it down every month's unit consumption, as in 600 units, 700 units, 200 units, 100 units. Like I have a curve, very smooth curve. Like in summertime, it goes like a stupid high. Again, air conditions, India, hot, it drains energy like there is no tomorrow. But in winter time, it comes down very low. So that's how we can calculate this. Now, right now, the easiest solution we have, because again, we do not have advanced enough setup yet, that we just buy too much of it. It's like, you have the money, you just buy as much lead acid battery you can do, or you have as much lithium ion as you can do. But again, that creates a penalty of, A, it's expensive, meaning more people can't do it. Wasteful, you're literally wasting resources, and it's huge. So not everybody has the physical space to put these things, especially with lead acid. There requires a big room, and be mindful, once you have that much lead acid, you have to worry about hydrogen escapement. Yeah, if you do not have a good vent to it, it might go boom. So these two things are what you call independent, and you want a system that is independent, as in, hey, I do not have very high load demand, but again, sun is not shining for very long duration, so I need to charge all my puppies very quickly, have as many battery as possible. Or it could be completely different. Hey, I don't have, like, I'm completely comfortable with grid, I just want some backup, but I want power. Like, I want power. Like, for example, your induction cooker, it drains power like there is no tomorrow, but it only drains it for a few minutes. Like, the tap is huge, but it's like, it's very small. Like, again, if you are trying to make tea on induction, you're barely gonna do that for 10 minutes, barely, not even 1 hour. So unit consumption is not that high. Power is high, unit is not. So power and energy is completely different. So ideally, you want companies to give you a solution where it's like, you decide based on what you have, and should have enough flexibility. Oh, I bought one inverter, it's not meeting my requirement, plonk, second one, more power. It's like, okay, I'm not happy with the battery, plonk, second one. That's why you need flexibility in design, and I'm very happy this sort of design are becoming far more common. And again, many companies are doing it, and finally even Indian companies will start doing it, let's just say by end of 2026. Now we come to, because again, we are talking about a lot of money, lifespan. Now, we all started with lead acid battery, and if you want to see still some big ass lead acid battery, go to your nearest substation. Of course, get their permission, but they have a room full of lead acid battery. Even some old mobile towers also have lead acid battery. But again, lead acid is not a good technology. It was earliest technology, it's not that good. The cycle life is measured in hundreds, as in like 500 to 1000. And again, 1000 you're not gonna get it, but that's how much company is stretching it. And you're like, okay, that sounds very low. Yeah, it's very low. Meaning, if you have a lead acid battery and you're draining it, charging it to 100%, draining it to zero, you'd be lucky to get like even 200 or 300 cycle. Like that's how it's supposed to be measured, and that is brutally low. Meaning you'll be lucky to get 5 years. And on top of that, the round trip efficiency is really bad. Meaning your solar panel now has to be extra large just so it can compensate for the round trip efficiency problem. 70%, meaning 30% of your energy would be kaput, just lost. Again, that's why the hydrogen is coming out of that, and that's why you have to keep dumping water again and again. It's literally electrolyzing. It is like an electrolysis cell. So fundamentally, it is wasteful. Again, from lithium system, full package lithium, as in like full inverter and battery, you can achieve 95%. These puppy 70 is like, bro, take it and go home. So that's creates a scenario. Now here's the, if lead acid has this many problem, how the heck we run substation, mobile towers, submarines on those puppies? Well, there is a simple solution to this. Overscale the hell out of it. Meaning, if you're making a diesel submarine, it's like, okay, this puppy need to run a 1 megawatt motor full bore. Like let's just say your power draw full bore is 1 megawatt. You design the battery bank that can supply 8 or even 10. And then or even after like 15 years, you'll be like, okay, it can only provide, but at least you can function. So that's why it's not suitable for grid. Again, you can force it, but again, penalty is you have to overscale the hell out of it. You have to reduce the C loading. For example, this is a simple graph of how much load affects the capacity. So if you have 220 amp hour cell, a cell is 220 amp hour, and you are loading it around 11 amps, you're gonna get 10 hour of runtime. Decent, very decent. But here's the, what happens if you are running some heavy load? You drain basically 104 amps. Yeah, this puppy runs out in 30 minutes. That translates to 60. You literally, the energy goes down from 100, even though physically is there, you go down to 60. So amp hour drops dramatically quickly if you have basically high loads. So that's how submarine people deal with it. Just like have huge cells. It's like so overbuilt it that even with that massive draw, the C rating, it's like, you know, it's here, not here. Lithium is exponentially better, like exponentially. So that is why it's not suitable. And again, if you discharge, deep discharge, like full 100%, full 0%, you will be shocked how quickly even like branded lead acid battery will kaput itself. So that's creates an issue. Now, thankfully, we do have a lot of chemistry options in lithium ion. For example, the reason why I'm not looking into Ola's battery, even though it will be, I think, India's first option, I was like this close to pre-booking it. First, people said to the company not did it. Second, I lost interest the moment I saw the battery was nickel, cadmium, manganese. I was like, no, you do not give NMC battery. That battery catches fire. Now, I'm okay with my car catching fire because I'm coming from a car that has fuel into it, which has petrol, which goes kaboom. I'm okay with that. I'm not okay with my house having something that can go kaboom. So I'm like, hey, do not give me something that only works as long as the active systems are working. Give me something that is passively safe. So that's why I lost interest in that packet. But thankfully, there are two chemistry that take care of us, which is lithium iron phosphate and lithium titanate oxide. Now, these two puppy do come with one big penalty. The capacity is lower, meaning how much kilowatt hour you get is low. Like if I give you 1 liter of volume, how much oomph you can have, like how much kilowatt hour you can have, not that great. However, while that being said, it does have power, as in like, it's like, I got this. Like you can load that puppy. It's like, are you doing something? Like lithium titanate oxide is stupid, as in like 3 to 5 C loading is like, are you doing something? Like, by the way, many of them have to pass almost 3 C of loading, 0 to 100%, 1000 cycle. That is unimaginable by any other chemistry. Lithium iron phosphate also does not go that high. Like lithium titanate is like, if you need like a very small, like a high power pack, that's your power puppy. That's like, I got this. Lithium iron phosphate is a bridge between these two technology. One has the power, maximum power, one has the maximum capacity. What if you need something in between? Lithium iron phosphate, and passively safe, meaning it does not burn. I'm like, okay, why not go to sodium and all that? Yeah, sodium has two problems. First, it's not real, as in right now it's not ready for the prime time, because again, the voltage drops so low that your amp rating goes stupid in the DC bus. Nobody can give you that. Like even though chemistry can go from 100% to 0%, by the time it's reaching 50%, as low as 50%, it voltage drops so low, it's like your inverter circuit is like, bro, I can't go that low. So it's difficult, like let's just put it that way. Right now that is not there. And on top of that, if it catches fire, as in like some bad events happen, it releases some naughty gases, as in like not just clean hydrogen. And yes, I'm saying clean hydrogen because that's how toxic those puppies are. So I'm like, lithium iron phosphate or lithium titanate oxide. Titanate oxide is like, it does not care. Lithium iron phosphate is goes and nickel manganese cobalt kaboom. So fundamentally, these two are the only topology that as of now 2025 ready for prime time. And what does it mean by lifespan? It simply means 80% of the capacity at the end of life, as in when it reaches 80% of its actual capacity. So you bought a 100 unit battery, once it reaches 8 unit capacity, you'll be like, oh sorry, 80 unit capacity, you'll be like, bro, this is kaput. When would that happen? Now solar panels have made amazing progress. We started solar panels with 5-year warranty. Now we are at 25 year warranty. 25 years, 80% of capacity. So your battery should match that. Now lithium iron phosphate can almost match that, and titanate oxide can easily match that. It's just that we don't buy titanate oxide because A, it's very expensive, B, it's huge. Like, it will take space. But again, you buy that, you put that in satellites and you do not worry about it. You put that in a military vehicle, you do not worry about it. It's like you put it and forget it. Lithium iron phosphate is a good middle ground, and it does have power. Like, it can fit, and it also sustains 100% to 0%. It's like, I got this. So that's why lifespan matters, because if you are investing so much money, I've gone through way too many lead acid battery in my household. Like, it's painful. It's becoming economically painful. I'm willing to invest into lithium ions because I can't afford lead acid. Even though it's cheaper, I have to keep filling it with water. And again, this time I made sure the water is not contaminated. I bought Exide water to make sure that water is not an issue. Still does not last very long. So I'm fed up with lead acid. It's like I have to go to lithium. And again, I'm waiting for good inverters. Battery is there, inverter is not there yet. So what can we expect in the future? Well, reality is paradigm shift for household energy is happening. Like, we went from that, like what we have right now in this world, China, India, USA, if you had said this like in 2000, year 2000, as in I was there alive at that point, nobody would have believed you. Nobody would like, oh, you're telling me every household will have enough surplus energy that is like it's giving back to the grid. Is like, what are you smoking? But again, we reached that point. So it is changing. And battery gives certain level of luxury in terms of resilience. It's not giving you oh, I'm king. No, it's giving you resilience, and that resilience also translates to your grid. Also, grid is like, hey, during daytime factories go YOLO. I have the surplus capacity. It's like, I'm good, I got this. That is good. That is flat out unmatched. And again, this also helps you with the uptime. So there are a lot of benefit of having this sort of thing. Even, and again, most of these have the ability to either with some extra hardware, or sometimes directly the hardware itself has the ability to grid tie also, as in like it can switch. If grid goes down, it switches to battery. If grid is up, it switches to grid tie setup. Because again, if you have a battery fully charged, again, it will happen in winter. Like, if I am doing this in India, during winter, most of my power production would be wasted. But again, at that point in time, it would be better to sell it to the grid. So all that flexibility is really good. And this makes grid adaptable, because again, grid will of course have to have ginormous battery, let's say pumped hydro, coal power plant converted into batteries. Those things will be needed. But having so many smaller units also gives us a bit of a resilience, bit of a wiggle room. So that is a very good thing. And even one unit at peak time matters a lot. Like, price differential in a grid during peak demand time versus load over generation time, you'd be shocked how big the differential is. Like, people are saying, oh, coal power plants as a battery will not work because the price will not be very huge, because again, it wastes 70% of the energy. Yeah, the price gap is 5 to 6x nowadays. During the peak sun time, it's like, and again, like, every country has different economics to this. Some countries are like, whoa, just buy the electricity. We do not want to do curtailment. So at that point, you can buy for energy for dirt cheap, and peak time, sell it for very high prices. So you can make economic profit even if you are throwing away 70% of the energy. And again, if you are smart, you will not throw away that energy. You will use it with either water generation using low temperature thermal desalination if you are next to a coast, or you will do cooling system for district cooling, or heating for district heating. So co-generation. So at that point in time, like if you are like going all out, your sun is going all out, that point in time, if every battery can eat it up, that's awesome. During evening time, every battery is like, I got you. Grid is like, bro, don't burden yourself. That's like, shut up, take money. And again, it will not make sense with lead acid. It burns too much energy. You have to buy so much of it to justify it. And again, I urge you, or watch videos or go to substation near you. You'd be shocked how much lead acid battery those puppies consume. So How do we achieve this? Well, we make modular and scalable system. Right now, India has a lot of inverter setup, but those are very old school design. Like, oh, it's a 24-volt system. Oh, it's a 36-volt system. It's locked. As in, like, you buy it, it's locked. But we want something like this, meaning you buy the inverter unit, as in the power head, and then you buy the battery based on your requirement. If you're like, hey, I do not need that much, cool, have one unit, done. Like, hey, I do need more runtime, buy batteries. Hey, I need more power, I'm charging my electric car, buy more power heads. That is a desirable thing. That has to happen. And again, if these things are becoming as simplified that any Tom, Dick and Harry can do it, more people will do it. It's good for everybody. And assuming the batteries last long enough time, 10 to 15 years is minimum. But again, we are almost reaching there. Science is there, engineering has reached it, economics is like trying to make it work. And again, lead acid is not a competition. And again, resiliency at serious times becomes shut up, take money. For example, how the heck you think Ukraine is alive? They have worked their ass off to add resiliency. A lot of people have small generators, a lot of people have Jackery. I had no idea Jackery is that popular in Ukraine. But again, at that point in time, it's like, shut up, take money. And that's what you want. You want your country to be resilient under wartime scenario. So if you can survive wartime scenario, natural disasters and pandemics would be like, brah, minor inconvenience. So this is a very amazing future of a decentralized grid where you have resilience on a core level. And again, once you have two-way metering and a smart connection, things that can be done is like, damn. Be mindful. In year 2010, if you are told that California has to shut off full power production because again, they are producing so much solar, like that duck curve now, which has reached into, they are selling it, instead of calling it duck curve, call it California Valley because it goes down that deep. Nobody would have believed you. Only 2010, nobody would have believed you. We are here. These things are coming. It's amazing. I'm happy with the design and topology that people are moving to. And I'm happy that India finally, I've seen so much YouTube video. I wanted India to have it. One company is announcing it. So I'm pretty sure in next 2-3 years, this might become something that I would be able to afford. Hopefully, fingers crossed. So this was my presentation on basically the home energy storage that is changing and evolving at this point in time. Hopefully you have liked it, learned from it. In that case, please click the like button, share it with your friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.